Okay, so it's recording now. So what, let's see, give me a second. There we go. All right. I have a hard time moving this video thing around that it's not in my way. It's like driving me nuts. Okay. All right. So this first problem here on the homework, pretty basic. You integrate it, plug in the top bound, which you see plugging in 3, and then minus plugging the bottom bound in, which is just going to be minus 0. So you end up getting 12 for this one here. This next one, like, you got to remember your integration techniques. So what you're doing here is you're squaring this first. I got to plug my mouse in. Hold on. All right, you're squaring it first, right? So this is what you get down here. And then you integrate each one separately using your integration rules. Then you plug in the top number 1 into all the x's. Then you subtract. This is what's being done down here. You take -1 and plug it into all the x's. You just really have to be careful with your algebra. That's going to be like so important there. I'm going to zoom in. All right, so then here, I feel like this is Mr. Gillen's answer key or somebody else's answer key, but because it's not my handwriting. But so you're just adding these fractions, making a common denominator, adding it up, and then subtracting this quantity, which you make in a common denominator, and you end up getting 86/15. That's what you're supposed to get. Do you guys have any questions on that?
I got the 15 as the denominator, but somehow I got 6 as the numerator. I don't know what I did.
For up here?
Yeah.
3/15, 20/15. Just checking the work here. Okay, so this is -17. Okay, this part here is 43/15.
Okay, wait, I have all those numbers right, like the 3/15, like that whole row. So I think I must have just...
You probably just added wrong, yeah. Yeah, so go back and check that, Sammy. Okay. Any questions on part C?
But yeah, can you go over that exactly?
Yeah, well, it's x to the 1/2, right?
Yeah.
When you add 1 to the power to integrate, it's now 3/2. But instead of dividing by 3/2, we don't write it like this. We don't write divided by 3/2. We automatically take this fraction and multiply it by the reciprocal. So that's what's being done right here. And then you take the top bound 1, you plug it in first, so 1 to the 3/2 is just going to be 1, so that's 2/3. Then you subtract, take the bottom bound, plug it in for x, and you get 0, so your answer is just 2/3. Are you okay with that?
Yeah.
See, I don't understand. Like, why is that moving and this other writing's not? Huh. Oh, I think I got it. Hold on. Let's try something. Oh. Now it's gone. My theory's gone. Ah, like when you write up here, it stays. You see that? I don't know. Anyway, that's my excitement this morning. Okay, so I bet you guys had questions on this one.
Yeah.
All right, how do I make this different? Oh man, Palumbo. Okay, so this one over here. You're probably thinking, how the heck do you get from this to this? All right, this is like a reoccurring question. When you're dividing by one term here, you are taking it, this x to the fourth, and you're dividing it into each term in the numerator. So essentially, you're splitting it up into x squared over x to the fourth, and then minus 3 over x to the fourth. This reduces to 1 over x squared. This stays as 3 over x to the fourth. And then what you do from here is you move this up, make it x to the negative second. That's to get yourself ready to integrate. And you move this up, x to the negative fourth, to get that ready to integrate. And then when you add 1 to the power and divide by the new power, you get x to the negative first divided by negative 1, which ends up being negative because you pull this negative on the bottom out, 1 over x, because this x to the negative 1 moves this x down. Are you guys okay with that? And then this here, you bring it up, 3x to the negative 4. When you integrate, you get x to the negative third divided by negative 3. This negative 3 and that negative 3, they all cancel. So all you're left with is x to the negative third that moves down. It becomes 1 over x cubed. So plus 1 over x cubed. All right, and now don't forget your bounds. You always plug which one in first? That's a question. Which bound do you usually plug in first, guys?
The
2.
Good.
Right.
Yep. So you take 2, plug it in, you get 1/2 plus 1/8. Then you subtract, take 1 and plug it in. This so happens to be negative 1 plus 1, which cancels to 0. So you get negative 1/2 plus 1/8 is negative 3/8. So there's your answer for that. All right. Part E, when you integrate secant squared, it's tangent. That's, you got to know that. Okay, you can't forget your trig functions. And then plug in pi over 4 minus 0. This is just like the example we did in the notes. You end up getting 1. And then over here, this one is the most involved one. And we did another one like this for our ticket to leave. So what you do here is you find your vertex by setting the inside equal to 0. You get a vertex of 1/2. That's how you're splitting up your integral. So you're splitting it up from 0 to 1/2, then 1/2 to 3. You make a number line and you put 1/2, that vertex, on that number line. And you're testing to either side. So for example, if I take 1 and plug it in here, it makes the inside positive. So you keep that equation exactly the same. So that'll be the integral from 1/2 to 3 on that side. You're integrating 4x minus 2. If you take a number to the left of 1/2, say 0, and you plug it in here, ignore the absolute value. It makes that negative. So that means you take the opposite of that equation. So negative 4x plus 2. And that's what goes into this integral, because this is the left to the left of 1/2. Does that make sense? And then what you're doing is, this is getting on my nerves up here. You're integrating each part separately. So you've got to really take your time. So negative 4x squared over 2, those cancel to just negative 2. Integrate 2, you get 2x. Plug in 1/2 to both. Be careful, you get 1/2 for this first part. And then you integrate again. Be careful, this reduces to 2. Plug in the top number, then minus, plug in a half. That's this work down here. Okay, you're minusing a half on the bottom here, plugging it in to these. This is this work right here. And you end up getting, let's see, 12 for this second part. So you get a half plus 12 gives you a total of 12 and a half. That's your answer up here. Okay, you really have to be careful with your integration and plugging in. Okay. Do you guys have any questions on that? No, it was okay. Is it just the 6 of them? Oh, we got a lot of people. Hey guys. All right. The last one is just the average value formula. So you literally, it's super easy. As long as you memorize this formula right here, as soon as it says find the average value of a function, you're doing 1 over b minus a. Your a and b are right here. They come from the interval. Okay? So you just plug it in. So 1 over b, which is 1, minus negative 1, which is going to be plus 1, is a half. Then you integrate from negative 1 to 1, and you put the function in there. So you literally integrate it. Then you plug in the top bound 1. Then you minus, whoever did this work. So plug it into the top bound. Then you subtract, take negative 1 and plug it in. So it's negative 1/3 minus 3. Okay, and then you figure out what this is. So that's going to be 1/3 plus 3 plus 1/3 plus 3. So this ends up being 20/3. And then don't forget this, guys. That was your times 1 over b minus a from the beginning. So you're timesing by a half in the beginning, and that reduces to this answer 10/3. Right?
Wait, when we're like writing down answers, do we have to say like unit squared?
Nah, I'm not going to take off if you don't do that.
Okay.
So don't worry about that. I mean, just know it is unit squared because you're talking about area, but I'm not going to be super picky about that.
Yeah.
Okay. Anything else, guys? That was it, right? That's just the front there?
Yeah.
Okay. Hold on, I want to see something. See, why does this... when does it stay and when does it move? Like, that's my question here. You see that? See how that stays? Or I don't know. All right, I'm gonna end this video. Now I'm gonna end the recording.